Okay, guys, I think that we can start with the class. Go to the page 179. Page 179. The topic is writing functions. Okay, remember the way we are working is that we start the topic, for example, Monday, and we finish on Tuesday. Later, we start the other topic on Wednesday, and we finish on Thursday. On Friday, you send me the homework from Monday to Thursday. So if you want to start working in the other exercise, you can do it. We have 2 topics in each week, and the homework, it's always the same. It's the exercise that says guided practice. When you see the examples and you complete the exercises you have. Okay. So only if you want to work by your own. But if not, we are going to work the same way in the class. Okay. Writing functions. We have a question in here. Why to learn this? Why to learn to write functions? You can use a function rule to calculate how much money you will earn from working a specific amounts of time. For example, we suppose that Tasha babysits and charge $5 per hour. We have a chart below with the time worked and the amount of money earned. The time worked is going to be X and the amount is going to be the variable Y. So if, for example, the time worked is 1 hour, remember that she earns $5 per hour. So when she works 2 hours, she's going to earn $10. If she works 3 hours or 4 hours, it's going to increase by 5. You are counting by 5 in each one. So the amount of money Tasha earns in $5 times is the number of hours she works. You need to write an equation using 2 different variables to show this relationship. Remember, Y is the amount earned. And you associate the X with the number 5, that is the amount of money she is going to obtain. Because depending on the number of hours is the amount of money she is going to get at the end, right? So you can use this equation to find how much money she will earn for any number of hours. Okay. In this case, for example, I'm going to show you one. This is the amount of money she is going to earn at the end, right? You have one constant. You have one constant number in here. One number that keeps permanent in the equation. 5. That these are the $5 she is going to earn by 1 hour of work. But I don't have all this, only the 5. I need to multiply this by another variable. In this case, my variable is going to be X. I assign X to the number of hours she is going to work. So she obtains $5 for each hour that she works. So if, for example, she works 7 hours, X is going to be 7. She works 7 hours. You only replace the number in the value of the number in the variable. For example, Y is equal 5 and X is 7 hours. So you multiply by 7. So she is going to get $35 because this depends on the number of hours she works. So in this case, if she works 7 hours, she obtains $35. But what if, for example, she works more than these hours? If she, for example, in a week, in all the week, she works 40 hours. If X is 40, I'm going to replace on the value, okay? X is 40. And now I only multiply the $5 for each hour by the number of hours. 5 times 0 is 0, and 5 times 4 is 20. So she is going to obtain $200. This is a simple equation in this to write the function. This is the function to know how much money is she going to obtain. For example, in 1 month, if she on the month works 160 hours or more hours, extra hours, this is going to give you the number of the amount of money she is going to earn. We can graph this. We can graph this if, but I think that in this topic we are not solving graph. We graph on the 3.4. So we start doing solving graphics in Wednesday, I think. So you can see the example 1. We can use a table to write an equation. We are using a table to write an equation. And now we need to determine a relationship between the X and the Y values. Okay, on the X, you have, you count since 1, 2, 3, and 4. And in the Y, you have negative numbers. You have -2, -1, 0, and 1 again. The step 1 is to list the possible relationships between the first X and Y values. The first value for each one is, I have 1 minus 3 equal -2. You are looking for the relationship. You are looking, for example, how do you obtain the -2 in the Y? She is, in the book they are using 1 and they subtract -3 to obtain the -2 that is on the Y, the section of the Y. They are looking for how to obtain the values that you have on the Y's. For example, the step 2 is to determine if one relationship works for the remaining values. So on the step 2, you have the second number of the X is the number 2, right? You subtract -3 again, and you obtain that is -1. This is the second value I have on the Y. Again, with the same number, 3 minus 3. The first 3 is the number I have in the X, and the 3 I subtract is the 3 I obtain in the first part, is in the first example. Okay, this is 0, is the value you have in Y. The same if you do it in the fourth line, 4 minus 3 equal 1. But you can see at the right part, when you multiply in this, they are different values. For example, if you multiply the first part on the step 2, you have 2 multiplying -2. This is different from -1. That is the second value I have on the Y. And if you do it, and you do the same with -2 multiplying 3, this is different than 0. This is the number I have on the third line of the Y. And in the fourth line, it's incorrect too, it's wrong, because it's not the same result. So the first relationship works, but the other one not. So the value of Y is less than X. Is 3 less than X? Is 3 less than X because you have negative in here, so you are going to say that is less than. If you have a positive, it's going to be greater. You have to add. So in this case, it's less than. It's like to find a relation. For example, I have the values for the X, and I need to find a relation how I obtain the values for the Y. And in this case, we obtain a relation. When we subtract -3 in all the numbers, we obtain the numbers we have on the Y part, on the part of the the chart that contains the value from the y. So you can solve the same in the exercise that says check it out. Determine a relationship between the x and y values in the relation. You have the ordered pairs 1, 3, 2, 6, 3, 9, and 4, 12. You can write an equation using this, but we are not going to write in this one. The first step, if you write it on the chart, it's easier to see it if you write it on the chart. You copy all the values for the x first, and later you copy all the values for the y. So to input, the input of a function is the independent variable. The output of a function is the dependent variable. The value of the dependent variable depends on, or is a function of, the value of the independent variable. For Tasha, the amount she earns depends on, or is a function of, the amount of time she works. Okay, this is in the page 180. They're only explaining the independent variable and dependent variable. Okay, for example, in this case, we have the example of Tasha. She is going to earn an amount of money depending on how many hours she works at the day, week, month, depending, okay, in the number of hours. I have one independent variable and I have one dependent variable. This variable is going to depend on the other one to obtain one value. For example, in this case, y depends on the value of the x to obtain a result. That's true because, for example, y change if you have x equal 1 hour, change if you have x equal 3 hours, it's going to change if you have x equal 200 hours. So this variable y depends on the value of the variable x you have to obtain one number, one result, okay, and to obtain something. For example, in here, y depends on the variable x is 40, and when you have the variable x, it's going to change the result. So this is the variable that depends on the value of the x. So x is the independent variable. So now on the example 2, we need to identify independent and dependent variables. Sorry, just 1 minute. Okay. Example 2, identifying an independent and dependent variables. In the example A, we have to, in the winter, more electricity is used when the temperature goes down and less is used when the temperature rises. So the amount of electricity used depends on the temperature. For example, the dependent one is the amount of electricity, and independent is the temperature. So the independent is the value that gives you the result for the other variable. It's one variable that depends on the value of the other variable. Okay, I'm trying to you to understand the concept the first day. Remember, later we solved some examples. I think that this part, okay, I think this chapter is the easiest one. That's the reason why I explain to you this way. And we can continue with the example B. For example, the cost of shipping a package is based on its weight. For example, the cost of shipping a package depends on its weight. So the dependent is the cost because this value is waiting for the value of the other variable. in this case, the other variable is the weight. The weight can change, and if my weight change, it's going to change my cost, okay? Now, the example C. The faster Ron walks, the quicker he gets home. The time it takes Ron to get home depends on the speed he walks. Okay, this is kind of obvious. For example, if you are walking to your home, you are going to spend some time. But if you are running, you are going to take less time. So it depends on the speed you have. It depends on the speed you move. In this case, the independent variable is the speed, and the dependent is the time, because the time you take is going to change depending on the speed. So this is how to understand the variables, dependent and independent. The dependent one, like the name says, is going to take the value after you place the value for the independent one, in this case the speed, because the speed can change, and if the speed change, it's going to make my time change. It can increase or decrease. And the part that says check it out, again, you need to identify the independent and dependent variables in each situation. These kind of examples can help you if you want to practice more, but I always assign you the part that says exercise with the guided practice. And okay, in the other part, below the check it out, we have an algebraic expression that defines a function is a function role. For example, 5 times x in the equation about Stasha earning is a function role. If x is the independent variable and y is the dependent variable, the function notation is fx, or read f of x, where f names the function. When an equation in two variables describes a function, you can use function notation to write it. Okay, it's the same way we have it in here. You have y equal 5x, but we find this is not only a relation, it is a function. So you can represent this like f of x equal 5x. It's a function that depends on the value of the x. It's a function that depends on the value of the x. Because if the value of the x changes, the function is going to change its result at the end. So, guys, I didn't notice that the class finishes 2 minutes ago. I hope you understand the topic today, the theory at least. Tomorrow we are going to see the last part, the dependent and independent variable, and later we solve the example 3, 4, and 5. So have a nice day, guys. The people who owe me the study guide, you can send it today if you have it on your email, okay? Or you can look for it on the platform and you can send it, because I don't want you to lose the points. Remember that these points are for the test. So have a nice day, guys, and take care. See you tomorrow.